Hello, welcome to Astronautics for Exploit. This is Dr. Ayenshola Ogundele. Deep space water worlds, global oceans, planets, or moons with potential to harbor extraterrestrial life. The focus points are as follows: deep space water worlds and scientifically proven potential water worlds in the deep space. The deep space water worlds concept, formerly known to be a science fiction, is gradually becoming a reality based on several astronomical discoveries that reveal the possibility of existence of water in the deep space water worlds. In 1971, through research activities, it was shown that radioactive decay alone was likely sufficient to produce subsurface oceans in large amounts, especially if ammonia were present. Presently, Earth is the only known astronomical object to have liquid water on its surface. Hubble Space Telescope, Pioneer, Galileo, Voyager, Cassini Huygens, Kepler Space Observatory, and New Horizons missions, through their collected evidence, show that several outer solar system bodies harbor internal liquid water oceans under an insulating ice shell, and also the existence of thousands of exoplanets, about 50 of them of Earth size, in or near habitable zones. NASA's Europa Clipper spacecraft, launched on October 14, 2024, is on a mission to investigate the potential habitability of Jupiter's icy ocean moon Europa and to answer scientists' most fundamental question about existence of another life in the universe. Deep space water worlds. A deep space water world, also referred to as the ocean world or ocean planet, is a planet that contains a substantial amount of water in the form of oceans as part of its hydrosphere, either beneath the surface as subsurface oceans or on the surface, potentially submerging or dry land. Prior to the launching of planetary missions that commences in the 1970s, preliminary theoretical work was carried out to ascertain the possibility of the existence of water in the water walls. An artist's concept of a plume of water vapor thought to be ejected off the frigid, icy surface of the Jovian moon Europa, located about 500 million miles from the Sun, is illustrated in this picture. Scientifically proven water walls in the deep space. Examples are Europa, Callisto, Ganymede, Enceladus, Titan, TOI 1452b, Kepler 138 planetary system, Super Earth LHS 1140b, and K218b. Europa, one of Jupiter's moons, is thought to have a global ocean of salty liquid water beneath its icy crust. Scientists have several lines of evidence that support the existence of an ocean on Europa. Studies suggest that tidal heating could create a global subsurface ocean, and this supports ocean on Europa. Measurements of Jupiter's magnetic field disruption near Europa suggest that a deep layer of electrically conductive fluid is creating a special type of magnetic field. The picture here illustrates an artist's interpretation of liquid water on the surface of Europa. NASA's Galileo mission, launched in 1989, showed that Jupiter's moon, Europa, likely possessed a liquid ocean underneath its icy exterior. The Europa Clipper mission will travel to Europa to determine if it is habitable. This is the first time a spacecraft will travel to a water world. Researchers are interested in the mixing of water and rock deep inside Europa's interior, where nutrients and chemicals may be able to support microbial life, like the way ocean vent sites host life on Earth. The picture here illustrates Europa Clipper as it flies past the Jovian moon Europa, as Jupiter watches on in the background. Callisto is another scientifically proven potential water world in the deep space. Callisto, Jupiter's second largest moon, could also be home to a subsurface liquid ocean. Callisto has the most crested surface in the solar system, suggesting that the moon does not have any geological or weathering processes. Callisto's surface is covered in water ice, making up 25 to 50% of its mass. Oxygen has also been detected in Callisto's exosphere, the uppermost region of the moon's thin atmosphere. In the 1990s, NASA's Galileo spacecraft data suggested that Callisto may have a salty ocean beneath its icy surface. The picture here shows a model of Callisto's internal structure, showing a surface ice layer. Ganymede, Jupiter's largest moon, has a subsurface saltwater ocean that contains more water than all of Earth's oceans. NASA's Hubble Space Telescope in 2015 found evidence of water vapor in Ganymede's atmosphere, and the moon's magnetic field suggests the presence of a subsurface ocean. This water vapor is the result of ice sublimating from the moon's surface. The picture here shows Hubble finds first evidence of water vapor on Jupiter's moon Ganymede. Enceladus, a moon of Saturn, has a global ocean of liquid water and is one of the most intriguing places in our solar system for searching for signs of life. Scientists believe that Enceladus has a salty liquid ocean beneath its icy surface. The Webb telescope has revealed a plume of water vapor from Enceladus that is more than 20 times the size of the moon. In 2005, Cassini spacecraft discovered that water and ice are ejected from an interior ocean gushed from the moon. Enceladus, one of Saturn's many icy moons, is shown in this picture. Titan is an extraordinary and exceptional world. Among our solar system hundreds of known moons, Titan is the only one with a substantial atmosphere, and all of the places in the solar system, Titan is the only place besides Earth known to have liquids in the form of rivers, lakes, and seas on its surface. Titan has clouds, rain, rivers, lakes, and seas of liquid hydrocarbons like methane and ethane. The largest seas are hundreds of feet deep and hundreds of miles wide. Titan is thought to house an internal liquid water ocean, which could be home to life. Titan, as seen by the Cassini spacecraft, is illustrated in this picture. TO1 1452b in 2022, using data from NASA's Transiting Exoplanetary Survey Satellite, an international team of researchers discovered exoplanet TOI 1452b. The planet is about 1.6 times the size of Earth and is classified as a super-Earth. It is 5 times as massive as Earth, and its density may suggest that a large percentage of the planet, potentially 30%, is composed of water. TOI 1452b, which is about 100 light-years from Earth, is a prime candidate for further observations with the James Webb Space Telescope. An artist's impression of TOI 1452b orbiting one of the red dwarf stars in the binary system is illustrated in this picture. Kepler 138 planetary system, a red dwarf star located around 218 light-years away from Earth, is notable for containing two exoplanets, water worlds, Kepler 138c and Kepler 138d, which are believed to be primarily composed of water. Due to their low density, scientists believe that Kepler 138c and Kepler 138d are primarily made up of water, potentially constituting a large portion of their overall volume. The water on these planets is likely to form extremely deep oceans, potentially hundreds of times deeper than Earth's oceans. The picture here illustrates an artistic impression of the Kepler 138 planetary system. Super-Earth LHS 1140b system. According to recent observations from the James Webb Space Telescope, Super-Earth LHS 1140b is considered a promising candidate for a water world, potentially covered in ice with a possible liquid water ocean, placing it within its star's habitable zone and making it one of the most intriguing exoplanets for potential habitability studies. In July 2024, Researchers using the James Webb Space Telescope observed an atmosphere on the exoplanet, which may sustain a liquid ocean on its surface. The planet orbits a red dwarf star 5 times smaller than the Sun and light years from Earth. Two possible versions of LHS 1140b is shown in this picture. K218b system. K218b is an exoplanet where astronomers have detected the presence of water vapor in its atmosphere, marking the first time water has been found on the planet within the habitable zone of a star other than our Sun, suggesting the potential for liquid water to exist on the surface. This discovery was made using the Hubble Space Telescope. K218b exoplanet resides within the Goldilocks zone of a star, where temperatures could potentially support liquid water. K218b is considered a super-Earth, meaning it is significantly more massive than Earth but smaller than Neptune. The picture here illustrates K218b, which has shown to have water and may have temperate conditions that could support life. For more information, contact Astronautics for Exploits. You've been watching and listening to Deep Space Water World's presentation, Global Oceans Planets or Moons with Potential to Harbor Extraterrestrial Life, presented by Dr. Ayansola Ogundele, with the focus point Deep Space Water Wars and scientifically proven potential water wars in the deep space. Thank you.